Good morning, student. Today we have topic reinforcement learning in machine learning subject. The purpose of this topic to understand how we can understand the third type of the machine learning, that is reinforcement learning, because we are much aware about there are three types of the machine learning. One is the supervised learning, unsupervised learning, and next one is reinforcement learning. Unsupervised learning and supervised learning we have already seen and discussed in various way. So now it's time to see reinforcement learning. So start. Everybody is making a big question or doubt about machine learning these days. When talking about the machine learning, reinforcement learning is another topic that comes into focus. So let's explore some stuff about reinforcement learning today. If I talk about the introduction to reinforcement learning, or as we can say this is a definition of the reinforcement learning. So it is comes in our mind. So machine learning is a subset of the artificial intelligence which provides machines the ability to learn automatically and improve the experience without being explicitly programmed. So this is a few or important line about the machine learning, why we are going through the machine learning. But if I talk about the reinforcement learning, which is the kind of the machine learning, is a type of the machine learning which is all about taking suitable action to maximize reward in a particular situation. It is employed by the various software and machines to find the best possible behavior or path it should take in a specific situation. Reinforcement learning means to establish or encourage a pattern of behavior. So this is the few line definition of the reinforcement learning which exploded. Then some rewards is a important part to follow reinforcement learning, because after applying the reinforcement learning in such a case, so the gaming application is a good example. So reinforcement learning we have in various area, various application we need to look for such thing. So forward to another slide and see how we can implement such kind of the reinforcement learning in today's era and how it is working. So start. For understanding reinforcement learning, first we have a simple example. Imagine that you are lost on an island where there are no human outside. Your first reaction will be to freak out and slowly figure out how to survive, what to eat, what not to eat, where am I going to sleep, and stuff like that. It means that you have to adjust to the new environment while learning from your all the experiences that might come across. Reinforcement learning is just like that. It is learning method wherein an agent interact with a new environment using actions and discovering errors or rewards. Reinforcement learning is all about taking appropriate action to maximize the reward in a particular situation. So this is a simple example by which we can say what is mean by RL and reinforcement learning, and we can use such reinforcement learning in theoretical to practical. So from the real life example, we need to understand how real reinforcement learning will work. So this is a simple example. Before moving ahead, we have differences between supervised and reinforcement learning. The definition part can be understood by supervised learning, that is works on existing or given sample data. And if I talk about the reinforcement learning, then it works on interactive with some environment. If the preference will be given to the supervised learning, that is assessed are depreciable, while reinforcement learning liabilities are non-depreciable. And task can be understood by the classification regression in supervised learning, while reinforcement learning we have exploitation and exploration. If we talk about the platform and other parts, so platform can be understood by the reinforcement learning operated with interactive software or applications, while in case of reinforcement learning we have supports and works better in AI where human interaction is prevent. An algorithm can be understood by the unsupervised learning with the help of the various or many algorithms that is exist using this learning. While in case of the reinforcement learning, neither supervised nor unsupervised algorithms are used. And if I talk about the last point, that is integration, so it run on the platforms or with any application. This is the case of the supervised learning, which while in talk about the reinforcement learning, it runs on any hardware or software devices. So these are little bit differences between the supervised and reinforcement learning. Like differences between supervised learning and reinforcement learning, we have over here unsupervised learning versus reinforcement learning. So differences can be understood by an easy manner as shown by the PPT. So first point we have over the definition. Definition in unsupervised learning can be understood by no external teacher or pre-trained data is required, while reinforcement learning works on interactive with the environment. The preference can be understood by unsupervised learning with the help of the assist are depreciable, while liabilities are non-depreciable in case of reinforcement learning. A task can be handled by unsupervised learning with the help of the clustering and association, while tasks are managed by reinforcement learning through the exploitation and exploration. And if I talk about the platform, algorithm and integration, all those cases are same as the supervised learning as we have into the previous slide. So these differences are same as into the supervised learning we have seen to the previous slide as I told you. Next point we have over here, we have not seen to the previous slide, that is a mapping between the input and output. So unsupervised learning, the mapping can be understood by the to find the underlying patterns rather than the mapping, while in case of the reinforcement learning will get constant feedback from the user while suggesting few news article and then build a knowledge graph. So this is the biggest difference we have in the unsupervised learning and reinforcement learning. So this is the few differences we have seen into differences between unsupervised learning and reinforcement learning. Now we have the very biggest question, that is what distinguish reinforcement learning from deep learning and machine learning. For understanding this topic, we have the simple and beautiful diagram into the next slide by which we can understand this question with as a solution. So let's see the answer in the next slide. In fact, there should be no clear divide between machine learning, deep learning, and reinforcement learning. It is just like a parallelogram, rectangle, square relationship, where machine learning is the broadcast category and deep reinforcement learning the narrowest one. In the same way, reinforcement learning is a specialized application of machine and deep learning techniques designed to solve problems in a particular way. So as the diagram is showing that there are two important axes. One is a problem and next one is method. If talk about the problem, so this problem is divided into the two important part. One is we are just known about the problems and knowing the answers, and the problem can be sort out done by the help of the policies by which we can solve the problem. So these are the two categories by which we can go for the problem, and this is represented by the problem axis. If we talk about the method axis, then a deep neural network we have, and next one we have the shallow network, or this is under come into the decision tree, and we have the also in case of the SVM, that is a support vector machine. If if you are just familiar with the known the answer, then problem can be solved by the or by method what method we have, that is a classic machine learning method. So this idea is taken solved by shallow network, decision tree, or SVM. But in case the problems the known and the answer we are known, and if we talk about the deep learning, then what kind of network we need to go for, that is a deep neural network. Same case we have the reinforcement learning, the policy or problem we know to solve such problem, and reinforcement learning have the classical approach. Then we can solve such by the help of the any kind of the method which could be SVM, dysentery, or shallow network. But we talk about the deep reinforcement learning, then it is a combination of deep learning as well as the reinforcement learning. So the policy and problems are known. In the case of deep learning, then such kind of the learning is known as deep reinforcement learning, and such kind of learning is followed by the deep neural network. So this is a simple diagram or simple notations or simple approach by which we can say the it is a combination of or distinguish between deep learning, reinforcement learning, and machine learning. So this diagram clearly shows that you what kind of the approach you need to go depend on the what kind of problem you have. So it depends on the problem, it depends upon your solution. So it is a user to user or problem to problem, such things vary. So this is the point you should keep in mind what kind of problem you have and what kind of approach you should apply to solve such problems. So this is the simple things we have seen. A reinforcement learning setup is composed of two main components, an agent and an environment. So these are the two important components by which we can understand the framework or the architecture of reinforcement learning. If we talk about the each and every point or each and every point in terms of a detailed manner, so we can see the first one is agent. Agent is a hypothetical entity which performs action in an environment to gain some reward. Actions, what is action? So action is means all the possible moves that the agent can take. And environment, so environment a scenario the agent has to face. State, state means the current situations are written by the environment. The reward, that is R, an immediate return sent back from the environment to evaluate the last action by the agent. Policy, policy just we have, that is the strategy that the agent employs to determine next action based on the current state. Next one is the value. So the expected long-term return with discount as opposed to the short-term reward, that is R. So V pi or V just another symbol which is define the expected long-term return to the current state as under the policy pi. So pi is a symbol by which we can denote the policy. And q value, the q value is also known as the action value, that is q. The q value is similar to the value except that it takes an extra parameter. The current action a, that is q pi sa, refers to long term return to the current state taking action and under policy pi. So this is a basic or small framework architecture of the uh, reinforcement learning. There are two important components, that is the agent and environment. So the clear diagram is showing that the agent is performing some action, that is at means the section which is performing on the some time t, followed by the some environment and having some information. And the environment generates the state, that is a s, that is a s t plus 1. So it means that there's a certain state which is occurred by the particular time and which is used by the next time, that is a time t plus 1. So same case we have the reward, that is r is a reward which could be used by the another state if required. So that is a rt plus 1. This is also the reward which is used by the next time, that is a rt plus 1. So if rt represents the reward which is generated by the current time reward. So state st means the state which is generated by the next current state. So this is overall approach of grabbing by the two important factor which are represented by the known by the agent. So agent will keep the reward and state for the next or next to next state for the coming. So this is a simple flow diagram by which we need to understand how many component we have and how these component flow one place to another place, or how these are the combined or making the combination or making integration part. So this is the idea about the framework. Now next question we have, how do RL work? So a basic reinforcement learning involves these steps for the working. First one is observation of the environment. Next one is deciding how to act using some strategy. Third one is acting accordingly. Fourth one is receiving a reward or penalty. Fifth one is learning from the experiences and refining our strategy. And last one is iterate until an optimal strategy is found. So this is the sixth point, is the most important point, because this is the point where we have just some algorithmic steps, or we can have the various technology or techniques we can see. First one we have the MDP, that is Markov decision process. Next one we have Wellman equations. Next one is policy based method. So there are various methods by which we can iterate until an optimal strategy is found, the approach we can have here. So the working of the RL can be done by the all these six steps. So this is just steps by which we can understand how RL will work. Now we have the biggest question again, that is what are the various approaches of implementation of reinforcement learning. The first we have, that is value based. In a value based reinforcement learning method, you try to maximize a value function, that is VS. The main focus is to find an optimal value. If we talk about the second point, that is a policy based. In a policy based reinforcement learning method, you try to come up with a policy such that the action performed at each state is optimal to gain maximum reward in the future. The main focus is to find the optimal policy. And third approach is model based. In this type of reinforcement learning, you create a virtual model for each environment, and the agent learns to perform in that specific environment. So these are the three important approaches by which when you need to implement RL algorithm or reinforcement learning approach or algorithm, then it depends upon the user requirement, or it depends upon the problem, what kind of the approach you are just applying to solve your problem followed by the reinforcement learning. So these are the three important approaches. User, students, and everyone has to keep in mind all these approaches. This is the important part. Now we have the applications of reinforcement learning. First application, that is robotics. RL can be used for high dimensional control problems as well as various industrial applications. Next application, that is text mining. RL along with an advanced contextual text generation model can be used to develop a system that is able to produce highly readable summaries of long text. Next application is trade education. Major companies in the financial industries have been using ML algorithms to enhance trading and equity. So this is application can be understood by the various financial sector are using ML algorithm to optimize such a problem where the problems is occurred in case of the financial education problems. So the applications trade education is such playing such kind of a deal into that area. Healthcare application we have, that is reinforcement learning is useful for medication dosing, optimization of treatment policies for those suffering from chronic or clinical trial, etc. So various kind of the medical problems can be diagnosed or prognosed by the help of the ML algorithms. So where the ML algorithms can be represent the reinforcement learning approach. So with the approach of the reinforcement learning, we can solve such kind of the problems which are related to healthcare. So this is the various applications where the RL is dealing. Next one is a game. Games is the most important application of RL because 60%, approx 60% reinforcement learning is using to game problems. RL is used so well known these days because it is the mainstream algorithm, as I told you, used to solve different games and sometimes achieve superhuman performance. So these are the various applications of reinforcement learning. Challenges with RL can be understood by the various points. So the main challenges in reinforcement learning lays in the preparing the simulation environment, which is highly dependent on the task to be performed. Transforming the model out of the training environment and into the real world is where things get tricky. Scaling and tweaking the neural network controlling the agent is another challenge. Another challenge is reaching a local optimum, which means the agent performs a task as it is, but not in the optimal or required way. So these are the two or three challenges which are occurring while developing or designing the reinforcement learning based model. So it depends on the user what kind of the problems he or she has on the basis approach has been applied. So depends on the approach or depend on the policy or depend on the strategy, challenges will be strictly shot out and get the optimum solution. So optimization is more important challenge or factor or issue which should be required to get the most and most reward, because the maximum award getting is a big situation in each and every state. So each and every state is required to have the good reward or best or maximum reward to go for the next state. So each and every state is just having the reward rather than the penalty. So maximum reward means you are just going to right direction and getting the good reinforcement learning model or following by the good approach. So this is the good things we have to go for. These are the various challenges. So these are two or three challenges that we have discussed over here. So today we have seen what is mean by the reinforcement learning and why we need to go for reinforcement learning and how it is different from the other kind of the reinforcement learning and what are the component of reinforcement learning. So these are the point we have already seen and discussed into the today's lecture, and there are some also points we have seen what is mean by the reinforcement learning having by some applications and challenges. So with the end of the challenge and application, so I'm just winding my lecture. Thank you for listening me.